So the next speaker is Kerim Dedioglu. He is working in the steel industry, Çimtaş Group and Enka for almost 25 years. And he was working from the construction sites through the fabrication to the quality control and the project management. And now is he the vice president of the Çimtaş Steel. So Kerim, please, you can start with your presentation.
Yes, I'll start my presentation now. Let me share my screen. Can you see it now in presentation mode?
No, it's the normal mode, not the presentation. Yes, now it's okay.
Okay. Good afternoon, everybody. First of all, I would like to thank to Eccs for arranging this webinar and inviting me for presenting in this event. Today, I'm going to talk about the possible solutions for the fabrication and installation of temporary bridges after the catastrophic events by keeping the recent earthquakes in Turkey in the center. Before starting my presentation, I would like to give you brief information about Enka and Çimtaş Group. Çimtaş is the subsidiary of Enka, which is one of the largest and oldest EPC companies in Turkey. Enka is active in oil, gas, and chemicals, power infrastructure, and building works. Enka was established in 1957 and completed hundreds of projects in 53 different countries with more than 60 billion USD historical contract value. Enka ranked in 53rd level in ENR top 250 contractors list last year. Çimtaş was established in 1973 as the subsidiary of Enka, which is the largest subsidiary of Enka, actually, with five companies and 7 fabrication shops in Turkey and China, where Çimtaş Steel is the flagship company of the group. We have 5,000 employees worldwide, and total fabrication capacity is around 380,000 tons per year. We are offering engineering, procurement, fabrication, machining, modularization, erection and installation services to the top tier customers all around the world. Çimtaş is also the fabricator of 1915 Çanakkale Bridge, which is the longest suspension bridge in the world, which you see the photo of the bridge behind me. On February 6th, 2023, there were 2 consecutive earthquakes of magnitude 7.7 and 7.6 occurred in Kahramanmaraş, Turkey, as Mr. Yener Güreş also mentioned in his presentation. These largest earthquakes in recent history caused varying levels of destruction in 11 cities in southeast of Turkey. Those earthquakes, which occurred in severe winter conditions, in harsh winter conditions, and the first of which occurred at night, reminded again the importance of roads and bridges, which are of great importance, especially the first aid, the first response, emergency response, and logistic support in the following days after the catastrophic events, not only in the earthquakes, but also the floods. In the following slides, I will also give some information about the big floods in Turkey as well. Floods that are becoming more frequently every day due to changing climate conditions cause great loss of life and property, as well as earthquakes, and cause heavy damage of infrastructure and superstructure systems. Bridges built over waterways are the first structures to be damaged by the floods. In this presentation, the major earthquakes and floods that have historically occurred in Turkey, the bridges that become unusable after these catastrophic events, what needs to be done, and some suggestions for the provision of bridges that can be fabricated and built quickly to replace the damaged bridges will be discussed as well. Here in this map, you see the geological location of Turkey. Turkey is located on a seismically active area with the complex zone of collision between the Eurasian plate and both the African and Arabian plates. As you see in the map, there are points in between those moving plates. Those are the earthquakes happened in Turkey recently in Kahramanmaraş and Hatay area. Much of the country lies on the Anatolian plate, bounded by two major strike slip fault zones, the North Anatolian Fault and East Anatolian Fault. The western part of the country is also affected by the zone of extensional tectonics in the Aegean Sea, caused by the southward migration of the Hellenic arc. As it can be seen, Turkey is located on the junction of three major and active plates that are continuously pushing the Anatolian plate through. Here in this slide, you see the major earthquakes and floods occurred in Turkey in the last 50 years. And I also listed the damage to the infrastructure and the bridges that those catastrophic events gave to the infrastructure. Like the big earthquake in 1999 in Izmit, which was the 7.6 magnitude, there was an extensive damage to the several bridges and other structures on the Trans-European motorway, including 20 viaducts, 5 tunnels, and several overpasses. Damage ranged from spalling concrete to total deck collapse in different levels of damage. Like the flood in Marmara region in 2009, 2 bridges on the Bahçeköy-Saray highway were destroyed. In August 2021, floods in Bartın, Kastamonu, Sinop region damaged 6 bridges in the area. And finally, the recent earthquake in Kahramanmaraş, 7.8 magnitude, damaged almost 75% of the infrastructure, total infrastructure in 11 cities, including bridges. Here is the photo of a bridge located on one of the branches of Asi River near Hatay that was collapsed after the earthquake in Kahramanmaraş, as an example. In most of the cases, after the catastrophic events, the first response is from the military, as usual, because military forces are well organized and they are spread to the country, so they are the first party to respond in these kind of catastrophic events. But right after the military response, a civil initiative should take place in cooperation with army or official authorities as required, in order to establish a midterm temporary bridges instead of short-term solutions. As we have experienced in the recent earthquakes in southeast of Turkey, even military had some difficulties by reaching the site due to heavy damage on the infrastructure. Especially earthquakes can be predictable as historical data and seismological researches help us predict at least a time period and estimated magnitude for an approaching earthquake. Here in this slide, I would like to talk about a little bit about the advanced planning before the earthquake or flood. There are several fault lines that are predicted to create large magnitude earthquakes in Turkey, especially the northern Anatolian fault line, which is passing through multiple populated cities in Marmara region, including Istanbul. This is the fault line, which has created two massive earthquakes in 1999, causing dozens of thousands of deaths and several infrastructure damage in the country. Another massive earthquake in the same region is expected soon, as the stress levels is increasing in the last 25 years. So advanced planning and preparation prior to catastrophic events can minimize the impact of the emergency. As related to the emergency response to damaged or collapsed bridges and their repair or replacement, advanced preparation can minimize additional injury and damage immediately following the initial event by providing organized and timely responses to the various responsible individuals and organizations. In addition, advanced planning and preparation can also minimize longer-term issues associated with damaged areas and construction zones, such as driving safety, public accessibility, and traffic congestions, as well as minimize potential economic impact or disruption of services to the local region. So advanced planning is important for emergency response right after the disaster, but also important for short to mid-term planning in order to continue public services in affected region. Once the critical bridges have been identified and the ranked order established, I mean, the importance of the bridges are listed, an emergency response plan, an ERP, should be developed for each critical bridge. By developing an ERP for each critical bridge prior to an extreme event, initial response times can be shortened by identifying key personnel and organizations along with their contact information for the specific geographic region of the selected asset. In addition, pre-coordination between these key players will yield very positive benefits in a post-event environment. The development of a variety of response plans, the acquisition of key personnel information, and the acquisition of identification of selected materials, equipment, information, and organizations associated with the selected assets prior to an extreme event will also yield very positive benefits in a post-event environment. Emergency response plans. Metropolitan Municipality of Istanbul, I selected this one as an example because, as I mentioned, there is a approaching predicted earthquake in this region. I selected this emergency response plan as an example. Metropolitan Municipality of Istanbul prepared an earthquake master plan for Istanbul in collaboration with some universities big universities in Turkey, like Boğaziçi University, Istanbul Technical University, Middle East Technical University, and Yıldız Technical University. The main guiding principle in this plan has been the self-evident fact that while no natural disaster can be prevented from happening, the incorporation of well-formulated planning and technical countermeasures will mitigate damages and losses significantly. This well-organized and prepared plan is more focused on diagnosing the risk levels of existing infrastructure and identify the structures that needs reinforcement and reconstruction. As we have experienced in Kahramanmaraş earthquake last year, even the structures are strong enough, an earthquake with a ground acceleration can damage them. If structures, especially bridges, collapse in a sufficiently powerful manner, even after the risk level has been determined and the necessary reinforcement has been made, they must be repaired to repair very quickly in order for emergency response and rescue teams to reach the damaged areas. To replace the critical bridges that may be damaged after the disaster is to prefabricate the bridge sections and make them readily available for installation prior to potential damage. Of course, while identifying the critical bridges to be spared or backed up, we should be selective as there will be a commercial impact having those temporary bridges readily available. But I mainly focused on the technical part rather than the commercial part of this issue. So this can be a potential solution for quick response after the earthquake for the fabrication and installation of the temporary bridges. So there are several types of prefabricated bridge types that have been used to serve as temporary bridges during construction as emergency bridges, and in some cases, permanent structures after the catastrophic events. That's why I call it short to mid-term solutions, because prefabricated bridge elements and systems can also be used as permanent structures after the catastrophic event. In all cases, the prefabricated bridge or bridge components are intended to be quickly and easily assembled on site, minimizing the time required on site to construct or restore the bridge. Here in this slide, I tried to list and visualize some advantages of prefabricated bridge systems. The first one is the improved project delivery time, as most of the parts are prefabricated at a fabrication shop. Longer durability, reduced weather-related time delays, as the installation is relatively faster. The prefabricated bridge systems can reduce the weather-related time delays during the installation. Improved site constructability, as all connections are designed as bolted and pinned connections. And also, as a result of the bolted pinned connections, on-site construction time is reduced in these type of temporary bridges. Panelized truss systems is a kind of the temporary bridges, which are prefabricated bridge systems. After identifying the risky bridges and viaducts in the emergency response plan studies, a panelized truss system bridge can be designed for each specific crossing. I'm talking about rather than a standard temporary bridge, as we have listed those critical bridges and crossings in the emergency response plan, there may be some specifically designed bridges for each and every specific crossing can be fabricated before the catastrophic event occurs. Panelized truss systems are composed of prefabricated truss panels that are bolted and pinned together and floor beams that span between the trusses. Here in this slide, you can see a sample of this panelized truss system bridge. Here in this slide, I would like to talk about a little bit about the supply flow of the temporary bridge. First, we need to identify the risky bridges through the emergency response plan. And then the design of the prefabricated bridge system should be done. After the design is completed for this specific crossing, the engagement with the fabricator shall be done through an RFQ, request for quotation process, and all these kind of technical details should be completed. And then once the fabricator is selected, procurement, fabrication, and delivery of the temporary bridge is to be done. And after the fabrication is completed, the bridge should be stored near the installation site before the catastrophic event occurs. Here you see a sample photo which was taken in our shop in Gemlik, the Çimtaş fabrication shop, for the prefabricated bridge truss fabrication. This is an example of relatively heavier truss system, but while designing the prefabricated bridge, top cord, bottom cord, and the bracings can be separated with bolted connections in order to avoid heavy installation equipment need at the installation site. Here is another sample photo of a prefabricated bridge truss taken in our shop again. So as a summary and conclusion of all items discussed, I have listed some items here as the suggestions and conclusions. Prefabricated temporary bridges, especially panelized truss systems, may help quick replacement of damaged bridges after catastrophic events. Prior to predicted disasters, bridges with high risk factor should be identified and reinforced or replaced as soon as possible. Bridges with higher importance for the post-disaster recovery should be spared or backed up with a temporary bridge. Specific design for each critically important bridge can be made, and specific panelized truss system can be fabricated prior to catastrophic event. Emergency response plans and execution plans for the application of temporary bridges shall be prepared in collaboration with governmental organizations, municipalities, universities, and public and private companies, which can design, fabricate, and install temporary bridges. Thank you very much for listening. If you have any questions, I will be glad to answer.
Thank you very much, Kerim.